Hi, and welcome to the second of two videos for section 11.3, the section on hyperbolas. So part of these problems, you're going to have to identify the foci, you're going to have to identify the vertices, you're going to want to sketch sketch the functions, sketch the hyperbolas. So this is our steps on how to sketch a hyperbola. So the first thing we're going to do is sketch what's called the central box. So once we do an example of this, we'll see what we mean by this idea of the central box. Step 2, we're going to sketch the asymptotes. So these asymptotes tell us how big the curve is on these hyperbola equations. Once we do that, we're going to plot the vertices. And once we have that done, then we just sketch the hyperbola. And we know it's going to look like two parabolas opposite of each other. So I'm going to erase this so we have the whole board to do the example. Just as in the videos for the parabola and the video for the ellipse, we'll do one together. I'll give you guys another one, and then you can do that problem on your own. You can hit pause and try to work it through. But if you need to catch up on the writing here, hit pause. Like I said, I'm going to erase it, and then we'll do the example. Alright, so for this example we have the following. We have the hyperbola has equation (9x squared minus 16y squared) is equal to 144. So we want to find the vertices, the foci, the asymptotes, and then finally sketch this guy. So, as with the ellipses, with the example we looked at, we cannot have a 144 here. This has to be 1. So what are we going to do? Well, we're going to divide everything by 144. When we get that, the new equation we get is what? It's x squared over 16 minus y squared over 9 equals 1. So, let's say that the problem is on an exam and they didn't tell us that this is a hyperbola. We have to figure this out. Well, the first thing is we see the minus sign, so we do not know that that's a hyperbola. And then because of this x squared is the first term, we know this is a horizontal. So that means we're going to have a parabola pointing to the left and to the right. Now first step is to sketch the central box. So in order to do that, we need our value for A and our value for B. So this 16 is our A squared. Remember, the A squared is always first. Doesn't matter which one's bigger. The B squared is second. So if A squared is 16, that means that our A is equal to 4. And if B squared is 9, that means B is equal to 3. So, our vertices are what? That we can already get the information. So our vertices, because this is horizontal, is plus or minus A and 0. So in this case, it's plus or minus 4 and 0. Our foci, and I think in the first video, I gave you guys the formula for c squared. Let me have you add this to your chart. So foci for the horizontal is plus or minus c and 0. And for the vertical, it's 0 and plus or minus c. So I'll make sure I point that out in class, but I didn't give you those values. I gave you how to find c, but I didn't tell you that those were the points for the foci. So make sure you make the change to your notes there. So we need our value for c. Well, we know c squared is a squared plus b squared. So that means c squared is 16 plus 9, which is 25. So that means c is equal to 5. So our foci are going to be plus or minus 5 and 0. Now we need our asymptotes. Here's something else I didn't give you guys. I apologize for that. So the asymptotes, again, if you can make this change in your notes, I'll make sure I point this out in class. I apologize I didn't give this to you in the first video. So the asymptotes for a horizontal are y equals plus or minus b over a times x. For the vertical, it's y is equal to plus or minus a over b times x. So again, if you can make that change, I'll make sure when I give it the notes to you guys that I point that out and make sure you have it added to your notes. So our asymptotes for this one, because it's a horizontal, it's going to be y is equal to plus or minus b over a times x. So that's y is equal to plus or minus, well, our b is 3, a is 4. So 3/4 x. And then lastly, we want to sketch this. So step 1, Step 1 says we want to draw our central box. So what we're going to do is we're going to go out a units left and right. So that's 4. So 1, 2, 3, 4. 1, 2, 3, 4. That's also our vertices, as you notice, plus or minus 4 and 0. Then the other sides of the central box are our values for b. So we're going to go up 3, b is 3, so up 3 and down 3. And we're essentially just going to draw a box that has these values, 3 and 4, as the sides. Now, what's nice is that if we essentially connect the corners of this with our dotted lines, these are the lines for the asymptotes. So you don't have to worry about, oh my gosh, how am I going to graph y is equal to plus or minus 3/4 x. Once you have the box drawn, just connect the corners, making this X formation, and those are your asymptotes. Step 3 says, plot the vertices. Well, again, we already did when we made this central box. And so now we know this is a horizontal hyperbola with our vertices at plus or minus 4. So it just means that we're making these two parabolas, that we have to stay inside these lines of our asymptotes. And we get that graph there. This here in the black is the graph of the equation of the hyperbola that was given to us at the start. So that's the first example. I'm going to go ahead and erase this. If you need to pause it, go back, look at some of the numbers, figure it out, catch up on it, that's fine. Otherwise, I'm going to erase this. I'll give you guys another example, and then you can try it on your own. All right, so example 2 is a little bit different. It's not quite as straightforward as the other one. It's sort of that going backwards. So if you remember with like the section on parabolas, it gave us like a foci, and then we had to figure out what's the equation of that parabola. Same idea here, and this could be on the exam. Instead of just giving you an equation and you have to draw or sketch it, they could give you this information, and then you need to come up with the equation for the hyperbola and sketch it after that. So what we have is find the equation of the hyperbola with vertices plus or minus 3, 0, and foci plus or minus 4, 0, and then sketch this guy. So I know it's a little different from the first problem we did. There we were given an equation, we had to figure out this information and then sketch it after that. See if you guys can try this. I know it's a little bit more difficult, it's sort of a newer concept, but think back to how we did those problems with, say, the parabola. So now that we know that these are our vertices, that means what? That means that this 3 is our value for A. And that means that 4 is our value for C, because that's what's related to the foci. So if we know A and we know C, we should be able to figure out B, and then by sketching this thing, know if it's a horizontal or vertical, and we can kind of start piecing together the equation. So go ahead and try that. Hit pause. If you get stuck, you get frustrated, just hit play again. Come on back, and we'll work it together. All right, welcome back. Hopefully you guys were able to pull this out. So first, let's try to sketch this guy. So with this little bit of information we were given, it says the vertices are plus or minus 3, 0. So that means what? It means this one and this one. So we already know this is a horizontal hyperbola. So we know that we're going to have a parabola going this way and a parabola going that way. So because it's horizontal, what do I know? Well, I know it's going to be x squared minus y squared. I don't know the values that go in the bottom yet. It's minus because it's hyperbola. It's x squared first because it's horizontal. Excuse me. And this all equals 1. So our a squared goes under the x. Well, our a was what? A is equal to 3. So a squared is equal to 9. So that's the value we have to put in the denominator of this portion here of the equation. Now we need b squared to go underneath it here. So what do we know? We're given c and we're given a. So we know from the formula c squared is a squared plus b squared. So therefore, c is equal to 4, so 4 squared is 16. This equals a squared, which is 9, plus b squared. That's the value we're trying to figure out. So to get b squared, what do? I just subtract 9 from both sides. So that tells me b squared is equal to 7. I don't really need to take the square root because what I want here is b squared. So I'm just going to go ahead and put that value under here. Now if I want to draw my central box, my vertices are plus or minus 3. Because my b is equal to b squared is equal to 7, b would be square root of 7, which is what? That's between 2 and 3, right? Because 9 square root would be 3, 4 squared is the 2. So I know I'm somewhere between 2 or 3. Don't have to be 100% correct here because we're just this central box. And so our asymptotes going through the origin, because that's the center of this hyperbola, gives me a picture that looks similar to that. So that's what we needed. We needed the equation, which we have here. And then the sketch, which is a horizontal hyperbola with our asymptotes that we generated from that central box with our information from A or B. So that's the end of video 2 for section 11.3. Again, there's only 2 videos for this section. So come on back and we'll look at section 11.4, the section on shifted conics.